instead. Hey y'all, I didn't see you there. So we've got some math to do today. We're gonna work on multi-step equations, all right? Which is gonna be some terms that we need to know just real quick. Variable, those are the x's and the y's. Constant, those are the numbers, all right? And then combine-like terms when we get stuff together, and he's gonna also introduce something called collect-like terms. I'll talk about that in a second, all right? But we're gonna need those terms in order to do our work today. So, yeah. All right, let's get to the video, and I'm gonna get back to my shot, I guess.
Today's lesson is essentially picking sides. And what I mean is on an equation, you just need to pick one side or the other. So one side you are going to collect all your variable terms, and the other side you'll basically collect your constants. And once you get them all on one side or the other, you're really ready to solve the equation and get the.
Okay, I'm just going to talk real quick before he goes to an example. This is me, Mr. Wamstead. You can't see me, you can just hear me. He is going to set up an equation, all right, and it's going to have variables and constants. It's going to have variables and numbers. And what he needs to do, what we need to do, and he's got two different terms for it: combine-like terms and collect-like terms. What that means is we need to get x's with x's and we need to get numbers with numbers, all right? So the x's are gonna go to this side where the variable terms are, and the numbers are gonna go to this side where the constant terms are. X's are variables, numbers are constants, all right? Now how we do that takes a little bit of skill, all right? But what he means by combine-like terms is to join x's with x's and numbers with numbers. What he means by collect-like terms is that sometimes we have to do that. We have to go across sides. We have to go across the equal sign. If that doesn't make any sense, here we go. He's about to do some great examples.
So let's do some example problems. Okay. Our first problem's 7x equals 4x plus 15. Notice we have variables on both sides of the equation. So I'm just going to collect all my variables on one side, and I can collect it on either side. I'm going to pick the left side for my variable terms and the right side for my constant terms. You can pick that any way you want. I choose to do it for a simple reason. I like to look at the coefficient, and whatever side the coefficient is larger, and this side 7 is obviously larger than 4, that's where I want to collect my variable terms. That way I get to avoid negative coefficients. So to get the 4x off of this side, I subtract 4x, but if I do it from this side, I of course do it from this side. These are like terms, and so we can subtract them. 7x minus 4x is, of course, 3x. This 15 just goes for a ride, and at this point, we can just solve for x. Divide both sides by 3 to make the coefficient 1 here, and that is isolating the variable, and x equals 5. Okay, again, we're going to collect all our variables on one side. And I noticed that the coefficient here, 5, is larger than 3. So I'm going to put my variables on this side, my constants on the other side. So I want to get this constant, or this variable term off the constant side. And to do that, I'm going to subtract 3x. Of course, when I do that, it goes away, or basically it sums to 0. But of course, if I subtract 3x from one side, I have to do it to the other. 5x minus 3x is 2x. These guys just come along for the ride. And essentially, we're at a two-step equation now. I add 2 to this side and 2 to this side. We'll get rid of this 2. And notice that's a constant on the variable side. So I'm staying consistent. Variable, I have one variable term. Constant, I have one constant term. I'm ready for my final step, and that is to get the coefficient as 1. So I divide both sides by 2, and I get x equals 3. Okay, so what I have here, notice on the left side, I can simplify this first, and I will. I'm going to collect like term, or rather combine like terms on this side, 7x minus a 3x. Once I get to this point, it's all set up to do some collecting. And now I notice that my variable is larger on the right side. So I'm going to go ahead and collect my variable terms on the right side. And that's really where I like to focus, is my variable terms, because the x is what I'm wanting to get alone. And so it's important to me to keep my coefficients positive. It just makes it easier at the end. So we're going to subtract 1x from both the left side and the right side. And now I'm all set up. It's a typical two-step equation. I want to subtract 13 from both sides and divide by a positive 3 to get x alone. Our last problem, we have
May I have your attention, please? All cheerleaders, please report to the gym. All cheerleaders, please report to the gym.
Okay, that was weird. Okay, now we're going to go ahead and we can tackle this problem in one of two ways.
Okay, so there we are. We got 3 examples. All right, we're gonna go do some problems modeled after those examples and get to combining and collecting some like terms. All right, finding some solutions. I was working on my shot during the in between, so you guys are gonna be proud of me. All right, I'll see you guys later.